Greetings, mathematicians, and welcome to Filling and Wrapping 4.1. Today we're talking all about the surface area of cylinders. In the past, we've talked about surface area of other types of prisms, right? Triangular prisms, rectangular prisms, cubes, all of that good stuff. But today we're going to take our knowledge of circles and apply it to now finding the surface area of a new three-dimensional figure, the cylinder. So I have my notebook set up here, and you're going to copy down these questions. You're also going to either copy down this net that I've drawn, or you can use the lab sheet that was on the previous page of the Nearpod. Print that out and paste it in this spot. Okay. If you are drawing this net here, I do want to point out that this right here, this little space in between my rectangle and the lines on my graph paper, that is intentional. Okay, so please be aware of that. You'll notice it is the same on the lab sheet. Okay, it's important, I promise. All right, so you're going to make your way through and answer these questions here. So go ahead, copy down the diagram, copy down these two questions. All right, once you're done copying these down, I want you to go ahead and try your best to answer these. See if you can come up with a strategy. See if you can calculate to the best of your ability, calculate the surface area of this shape. All right, hopefully you've attempted this problem on your own, but straight away, when I'm calculating the surface area, I'm remembering, well, I know that I need to find the area of each side or each face of my three-dimensional object and then add all of those areas together. So in this case, I have three shapes that I need to find the area of. I have two circles and a rectangle in the middle. So, with all of our previous work, we can definitely find the area of the circle that has a radius of 3, right? And we have both of these. Then we have this rectangle here. It has a height of 4 and approximately 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Ooh, a little bit more than 18 going across the top. So I'm just going to estimate and say that the piece along the top, the length, I guess you could say the length of the rectangle here, I'm going to say is approximately 18.5. And so if we go ahead and calculate these areas, let's go ahead and do that. All right, let's take a look at these different areas. So I calculated the area of the circles, right, with a radius of 3. So I used the formula pi r squared. So 3 times 3 is 9. 9 times pi is approximately 28.3. And these two circles they're identical. So I know that both of their areas are 28.3. Now, for my rectangle, right, I'm just going to multiply length times width. So 4 times my approximation of 18.5 gave me 74. So once I found all of these areas, I added them together, and I got a surface area of around 130.6 centimeters squared. I know you're probably saying, well, Mr. RG, is there a way for us to not approximate? Is there a way for us to calculate exactly what the surface area is? And to that, I tell you yes. And I'm hoping that you see how these circles relate to this rectangle here. So this is actually what question A2 is hinting at here. Describe how the dimensions of the cylinder can help you find its surface area. So let's take a look at this really quick. Okay, I went ahead and erased some of my calculations. So the issue here is actually this piece right here, this blue line that I'm drawing, because that was the only thing that I needed to approximate when I was calculating my surface area. However, there is a way for us to calculate the exact area of this rectangle, and that, in order to do that, we need to relate this piece right here, this blue line, I need to relate it back to my circle. And so I'm hoping that you see that if you were to roll this circle along the edge of the rectangle, you'll notice that it actually wraps around the circle one time. So now I hope you can see these two corresponding parts. Now on my circle, what is this part that I just highlighted, that I just went around? Well, we know this. Starts with a C. Ah, yes. I hope you said I hope you said that this length right here, the length of the rectangle, is the circumference of your circle or of your base. And so that right there, we can definitely calculate the circumference of this circle because we're given a radius. And that right there takes all of the approximation out of your calculations here. So what we're going to write in A2, we're going to say that the length of the rectangle matches the circumference of the bases, of those two circular bases. And isn't that nice? Isn't that convenient? I hope you say yes, because that is awfully convenient. So now I want you to go back and recalculate your surface area for this problem. And let's see what we get. So I went ahead and calculated my circumference of my circle, and I got approximately 18.8, which is pretty close to my original approximation of 18.5. Being 3/10 away is it's a significant difference, but now we actually have a more accurate piece of data to work with. So if I multiply 18.8 times 4, that should give me 75.2 for the area of this rectangle here. And so instead of 74, I should write 75.2. And let me recalculate a little bit. So my new surface area, or I guess I should say my more accurate surface area, would be 131.8 square centimeters. And there you have it. So let's try it again. Copy down question B. This time you're going to draw your own net of a cylinder. You can just kind of copy the format of the one up here. Okay, but please pay attention. Please pay close attention to the dimensions we need. So we need a height of 5 centimeters and a base with a radius of 2 centimeters. I would like you to label your diagram and calculate its surface area. Okay, so remember, it doesn't need to be absolutely perfect, but I do expect you to, try and make your edges as straight as possible, all that good stuff. All right. So again, we are drawing a net for a cylinder with a height of 5 centimeters and a base with a radius of 2 centimeters. So go ahead and label the dimensions, please. So this right here is 2 centimeters, and then this right here is 5 centimeters. And really, that's all the information that we need to calculate the surface area of the cylinder. So go ahead, calculate the surface area, please, using this strategy that we used up here. All right, so we found the areas of the circles. We found the circumference to help us find that missing length of the rectangle. And hey, look at that. Actually, it turned out to be the same, almost the same thing as the areas, so 12.6. And then we found the area of the rectangle. Once you find the area of all three parts, add them together, and our approximate area is 88.2 centimeters, or square centimeters. Okay, so this wouldn't be math class unless I ask you to find a pattern here, or to describe what is happening. So I want you to take a look at the examples that we've done and try to describe a strategy for calculating the surface area of any cylinder. All right, so I'm not gonna share my answer here. We'll talk about it during our next class. And then I want you to use your strategy to calculate the surface area of the cylinder here at C2. Alrighty, thank you for your time today. You're awesome. I'll see you in the next one.